All right, so the last part of your worksheet is going to have a bunch of problems that look like this, which you're going to look at them and say, holy crap, what's going on? But the big thing to notice is just take a minute and look at the problem. Because if you look at this problem, you notice that right here, it's just two fractions inside of a fraction. Don't mind me crossing out that 9. So really what this is this is just one giant division problem. If you think back to day one, we did all division. So I have 3 over x divided by 9 over x squared. So remember, this is where we factor everything, which this problem, there's nothing to be factored. And then I take my domain. So I look here, I'm going to say, okay, x cannot equal 0. Once you have your domain, you're going to keep, change, flip. So I'm going to keep 3 over x. I'm going to change the division to multiplication. I'm going to flip 9 over x squared to x squared over 9. And then from here, I'm going to cancel what I can. So what you notice is I have 1x on the bottom and 2 on the top. So the x on bottom will cancel, and then I'm just left with 1 on top. And if you see here, I have 3 over 9. So that 3 is going to reduce down to a 1, and that 9 will reduce down to a 3. So my answer for this problem is just going to be 1x all over 3. Normally when you do the keep, change, flip, you have to go for your domain again, but my new denominator was just a 9, which means there was nothing else to add to my denominator. Sorry, to my domain. Over on this other one, it's the same idea. I have x divided by 3x minus 2, all divided by x all over 9x squared minus 4. So again, I'm just going to rewrite this as a more normal looking division problem. So that's x, 3x minus 2, and that's all divided by x all over 9x squared minus 4. This problem I'm actually going to be able to factor. The 3x minus 2 will not factor, but the 9x squared minus 4 will. So that's 3x minus 2 and 3x plus 2, because that's the difference of 2 squares. So when I go to write my problem, I have x all over 3x minus 2 divided by x all over 3x minus 2 and 3x plus 2. My domain for this problem, so far, if I set 3x minus 2 equal to 0 and solve it, that's going to give me 2/3. And if I set 3x plus 2 equal to 0, that's going to give me negative 2/3. So now that I have my domain, I'm going to keep, change, flip. So I have x all over 3x minus 2, and I'm multiplying it to 3x minus 2, 3x plus 2, all over x. Why I put a 9 there, I have no idea. All right, well, that's going to be rough. From here, you guys just look to see what can cancel. These x's will cancel since they're by themselves. I have 3x minus 2 on top and bottom, which means this whole problem just simplifies down to 3x plus 2. There's nothing left on bottom. One thing I did forget to do is after the keep, change, flip, I need to add into the domain again. So once I flipped it, I was left with this plain old x on the bottom, which means x can also not equal 0. So I'm kind of shove that back up there with the domain. So that's similar to the problem which you'll see on your homework. On this next page, it's the same idea, but if you notice, it's still this giant like division within a division. However, now I'm also adding or subtracting on top or bottom. So if you look at this first problem, I have 1 over b plus 1/2 divided by 4 all over b plus 1b minus 1. So the first thing I'm going to do is I'm going to write this as a division problem, but I'm going to put my addition in parentheses because this whole thing's getting divided, and so I need to take care of that first. And then from here, both of my denominators are different, so I need to multiply both fractions by the other denominator. So I multiply the first one by 2 and the second one by b, So now I have 2 all over 2b plus b all over 2b. And then again, that's all being divided by 4 all over b plus 1, b minus 1. So then I look again, and I can actually combine my like terms. So I have b plus 2 on top, and I'm dividing everything by 4 all over b plus 1, b minus 1. Okay, now that I took care of the addition, I have to do my domain and then keep, change, flip. So my domain is x cannot equal, for this 2b over here, that means it can't be 0. For b plus 1, I can't have a negative 1, and for b minus 1, I can't have a positive 1. So now I'm going to do keep, change, flip. Oops. It's weird that it does that. All right. So I keep b plus 2 all over 2b. I'm going to change this to multiplication and flip this to b plus 1, b minus 1, all over 4. The only things, nothing will cancel. I wonder if I meant it to be that way. So, since I don't see anything that will cancel, I'm just going to write my answer. So this would be b plus 2, b plus 1, b minus 1, all over 8b. All right, so there's your first example seeing addition or subtraction in the problem. I'm going to try and get everything to move at once. I don't know how. All right, try this. Then we have this other problem that's very similar. So I see over here I have x all over x plus 2 minus x all over x minus 2. So again, I'm going to rewrite this to make the problem look a little bit more normal. And that's all going to be divided by x minus 1 all over x squared minus 4. Here I don't have common denominators, so I need to multiply again. That should be an x minus 2. X minus 2, and multiply this side, x plus 2, and x plus 2. All right, I already said other stuff, so it wasn't on our way. But remember, I'm going to multiply throughs to the top, so that's going to be x squared plus or minus 2x, and I'm going to keep the bottom factored, so it's x minus 2, x plus 2, and I'm subtracting from it x squared plus 2x all over x minus 2, x plus 2. Since I'm running out of room, I'm going to leave that other guy alone for now. Now that I have common denominators, I'm going to change my sign and subtract everything. So x squared minus x squared, that goes away. But then I have negative 2x and negative 2x, so that leaves me with negative 4x all over x minus 2, x plus 2. So I took care of the subtraction in the problem, and now I just have to worry about this division. X squared minus 4, that's going to factor down to x plus 2 and x minus 2. So I'm going to take care of my domain. I have x cannot equal positive 2 or negative 2. That's for both of them. So we're going to keep, change, flip. So I have negative 4x all over x minus 2, x plus 2. I'm going to multiply to it x plus 2, x minus 2, all over x minus 1. Now that I flip this and I have a new denominator, x minus 1, I'm going to add to my domain that x can also not be 1. So I look here and I have an x minus 2 and an x minus 2. I have an x plus 2 and an x plus 2. And so this is going to leave me with negative 4x all over x minus 1. Because this x has that minus 1 attached to it, I can't cancel out my x's, and this is my final answer. I have this with that domain. I know this isn't ideal with me not being in class. Really sorry about that, but do the best you can. There's only 3 of these problems on your homework, so try and figure them out. I will see you Thursday or Friday.